Hi, in this video I'm going to look at the two examples from the previous video at the end of them. So if you haven't watched that video yet, go back and have a look at it. That way we can go through these examples knowing full well what's going on. Okay, so I want to draw this graph here, and I start off by noting that my degree will be 4. And that is that I have 1, 2, 3, 4 x's that will be multiplied together. This means that it's an even type function and that it will start and end in the same direction. Because it is a positive x to the power of 4, we're going to be starting going up and finishing going up or being positive. The next thing that I note is that my roots are going to be at -2, 1, and -1. Now, you'll notice that this 1 here has a squared on it. That means that it's going to act like a parabola at 1. So if I kind of sketch out where -2, 1, and -1 is, when I get to 1, it's going to act like a parabola. It's going to bounce off. The other thing to note is what the y value will be when x is 0. That means the y-intercept. So y is going to be 0 plus 2, 0 minus 1 squared, 0 plus 1, which is going to be 2 times, well, -1 squared is 1 times 1, which is 2. So it's going to cut my y-axis at 2. That's enough information for me to do a pretty good sketch. So I start going up, and I come down and I cross at -2. I'm going to go up to -1. When I reach 2, I'm going to come back down, and when I hit 1, it's going to act like a parabola, and it's going to bounce off going back up in this direction. Now my hands are a little bit wobbly on this screen, but you can see the general outline. We start facing up, or facing positive. We cross at the -2 where there's a root. We come back up and cross through -1. We reach the y-intercept, which is at 2, and we come back down. We don't necessarily have to come back down at 2, and then we come back down to 1, but instead of going through 1, we bounce off like a parabola. Again, not my best hand-drawn graph, but it'll do for now. In my second example, my graph is going to act like it's going to be an x to the power of 6. So it's going to start and end going up. And I know this because there is 1, 2, 3, 4, 5, 6 x's that are being multiplied. It's also a positive, so it's going to be starting up and finishing up, and not starting down and finishing down. Now, another thing that I know is that my values for x, my roots, are going to be 0, 3, and -1. Now, some things to note about this. At 0, it's going to act like a parabola. So I might just put a little 2 above that. And at -1, it's going to act like a cubic. Now, cubics look like an S shape, so that's what it's going to look like at -1. So if I put on my values on my graph, here's 3 and here's -1, I start to get a good idea about what it's going to look like on my graph. The last thing that I want to do is make sure what happens when x equals 0. Y is going to be 0 squared times 0 minus 3 times 0 plus 1 cubed. And because of this 0 being multiplied by everything, it means that my y-intercept is going to be at 0. So starting pointing up, I'm going to come down to -1. And when I get to -1, it's going to act like a cubic. And cubics are S-shaped. So it's going to come down low. It's going to keep going through, sort of like an S shape. Now I know that it bounces back up to 0. So we're going to come back up to 0. But it's not going to cut through 0 because 0 acts like a parabola. So it's going to bounce back down. Now, we don't know by now how far down this goes. But we do know that it's going to come back up and go through 3. And it's going to stay cutting through 3 on our x-axis. So this is roughly what it's going to look like. It's important that you show the S shape at -1 and show the parabolic shape at x equals 0, which is right here. Again, we don't know the value of y at the moment for this point here, but we'll learn that later when we do calculus.